Welcome to The Explainer. We're jumping straight into what I like to call an absolutely epic man versus scale and time story. Today, we're looking at the construction of Victoria's largest ever public health infrastructure project, Melbourne's mega Footscray Hospital. I mean, this isn't just about pouring concrete. It is a true masterclass in modern engineering, ridiculously tight logistics, and just sheer determination.
So let's take a quick look at our roadmap to see how Multiplex and the Plenary Health Consortium actually conquered this logistical mountain. We're going to cover ambition on a mega scale, logistics plan from day one, fast-tracking the superstructure, prefabrication and heavy lifting, a seamless moving day, and finally, orchestrating a healthier future.
All right, kicking things off with Section 1, ambition on a mega scale, designing for a growing community.
Now, context is everything here. Western Health is the second largest health service in Victoria, and it is growing fast. Their aging hospital was literally physically limiting their ability to provide care, which essentially demanded a massive public-private partnership replacement. But the sheer scale of this project is just antagonistic. Try to picture this. Coordinating 85,000, yes, 85,000 individual pieces of specialist medical equipment. We're talking everything from tiny fittings to massive heavy machinery, all spread across 16 completely airtight operating theaters. Every single piece had to be perfectly integrated with intricate interior services just to make the building function.
And to house all of that equipment, well, you need a true megastructure. We're looking at a total footprint of 192,000 square meters. To put those materials into perspective, it required 63,000 cubic meters of concrete. That's enough to fill 25 Olympic swimming pools. Add in 90,000 square meters of vinyl, which covers almost 5 Melbourne cricket grounds, and over 5,000 complex airtight facade panels. Bringing this whole shebang to life took a peak workforce of 1,500 people, dedicating a mind-blowing 7.1 million total work hours. Just incredible.
Moving right along to Section 2, logistics plan from day one. Designing the finish line first.
You know, to beat the incredibly strict deadlines of a public-private partnership, the engineering team couldn't just rock up and start digging. They actually had to plan the very end of the project before laying a single brick. Construction manager Michaela Jones hit the nail on the head when she noted that figuring out how to actually take the cranes down was one of their initial steps. Think about that for a second. They had to reverse engineer the placement and the safe removal of 10 massive tower cranes right from the start. They put up and dismantled all 10 completely safely, without incident, which is a massive logistical flex all on its own.
Pulling this off required some highly sequenced steps. Step 1, as we just mentioned, was that incredibly precise crane placement and removal. Step 2 meant mapping the structural steel and mechanical access. And Step 3, coordinating tight HEPA filtration for the airtight operating compartments. Seriously, if you looked up inside the ceiling spaces of the pathology and operating departments, there was virtually zero room to move. Every single inch was planned out from an infection control perspective to make sure these complex spaces functioned flawlessly.
All right, Section 3, fast-tracking the superstructure, agile construction in action.
Under the unforgiving timeline of this project, there was this constant, heavy demand for speed. But instead of cutting corners, which, let's face it, is a recipe for disaster, these time pressures forced project director Mike King to innovate using an agile approach. Normally, in a traditional build, you'd complete all your interior health planning designs before pouring the structure. Makes sense, right? But for the Footscray Agile build, early works for the structure and facade pushed ahead anyway. They progressively designed and poured structural slabs while the interior blueprints were literally still being resolved. They had just enough stability in the footprint to build the superstructure safely and efficiently without putting the cart before the horse.
Which brings us to Section 4, prefabrication and heavy lifting, engineering the climax.
So how do you maintain this ridiculous speed without sacrificing the safety of that massive workforce? Well, the engineers turned to advanced prefabrication. I mean, you can't fast-track a megastructure if you're building every single piece from scratch on site. Enter a brilliant engineering solution, precast V-columns. These are complex structural nodes that span multiple floors. Instead of risking a slow, potentially dangerous in situ pour on site, these massive columns were prefabricated off-site. They're actually beautifully showcased in the hospital's public spaces now. They were heavily supported by temporary steel framing as they went up, saving a huge amount of time and drastically increasing installation safety.
And speaking of heavy lifting, just imagine the sheer Discovery Channel level awe of witnessing this next part. A 120-ton pedestrian bridge.
The team partly prefabricated and fully assembled this absolute colossal structure just inside the hoarding on Ballarat Road. They did as much work as physically possible on the ground, and then, in one single jaw-dropping crane lift, they hoisted that 120-ton bridge right into place to connect the hospital to Victoria University. There is no way you wouldn't stop and watch that.
Okay, Section 5, a seamless moving day, the ultimate transfer.
All of this high-wire engineering and heavy lifting was leading to one single, uncompromising deadline. They had to open the massive new facility while simultaneously shutting down the old hospital. It's the ultimate balancing act, requiring a crazy tight timeline, and it is an absolute testament to their pre-planning. Over a 12-day period, they transferred 1,200 cubic meters of existing medical equipment. Then came the human element. In just a 10-hour window, 122 patients were safely moved based on their acuity. And on that February 18 go-live date, 0 delays. Absolutely none. It opened seamlessly, but only after executing over 500 rigorous acceptance tests, witnessed and reviewed by multiple parties.
Finally, Section 6, orchestrating a healthier future. By the numbers.
When you step back and look at how all these elements, the architectural design, the construction sequencing, the clinical workflows, when they perfectly align, it creates so much more than just an engineering marvel of concrete and steel. It creates a literal lifeline for Melbourne. We're looking at a facility for roughly 4,500 staff, housing 500 inpatient beds once it's fully operational. To put that into perspective, it brings the capacity to treat an additional 15,000 patients and handle 20,000 more emergency presentations every single year. Plus, it offers over 400 dedicated patient care spaces, ranging from consulting rooms all the way to the intensive care unit.
So, let's wrap up with a final thought to chew on. If tight deadlines and sheer, massive scale can actually push engineers to orchestrate such a masterpiece, what other community mega-projects could we fast-track next? The Footscray Hospital proves that massive ambition, when paired with strict timelines and brilliant logistics, can actually drive superior engineering outcomes for us all. Thanks for joining me on this explainer. I really hope this leaves you looking at the mega-structures in your own city with a brand new perspective.
And that wraps up today's explainer. Seriously, what a fantastic deep dive into those mind-blowing engineering concepts. I just want to say a massive thank you for sticking around and completing this journey with me. So let's get into it. Did you find these complex engineering concepts as utterly fascinating as I did? To get more amazing construction content, just follow this blueprint. Thumbs up, share, subscribe, and hit that bell. Which leaves one final question. What incredible structures are we going to build in our very next adventure?